Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from Probability and Statistics 1. And the question belongs to the paper 9709/51 for the session May June 24. We are solving question number 5, which says in a certain area in the Arctic, the probability that it snows on any given day is zero point 0.7 independent of all other days. Question number A says find the probability that in a week of 7 days it snows on at least 5 days. Well, we know that for solving any question in probability and statistics, first of all we will have to categorize the question whether it belongs to binomial distribution or geometric distribution or normal distribution. So let's analyze the given in data or information given over here. Look at this. It is written that total number of experiment is 7, which is given, and probability of each day is also given. As the total number of experiment is given, it must belong to binomial distribution. So how to know or how to identify a binomial distribution? If the total number of experiment is given, then that distribution belongs to binomial distribution. So let's start solving this. As x belongs to binomial distribution, we have already clarified binomial distribution, and the parameters for binomial distribution are total number of days, total number of weeks, total number of experiment is 7, and probability is 0.7. So parameters of binomial distribution are total number of experiment, which is 7, and probability of each of the day is 0.7. Then they have told that at least 5 days. Look, at least 5 days means it might rain for 5 days, or it might rain for 6 days, or it might rain for 7 days. That means it's 5 onwards, which is x will be greater than or equal to 5. Then how can we expand this? It may rain for 5 days, or it may, or means addition, the basic fundamental concept of probability, or it rain for 6 days, or it might rain for 7 days. So let's apply binomial formula, which is out of 7, 7 choose 5, and it rained for 5 days, sorry, 0.7 rained for 5 days. That means rest 2 days there was no rain, and for no rain probability is actually zero point 0.3. So 0.3 is q is equal to 0.3. Okay, means no rain, probability of no rain. Well, then from there was no rain on 2 days. Okay, after that 6 days there was rain. That's why we will write 7 choose 6, and it is probability 7. 6 days there was rain on 6 days, and 1 day there was no rain, and for no rain probability is 3, only 1 day. After that, out of 7, on all 7 days there was rain. So 7 choose 7, and all 7 days there was rain, and for no rain actually probability was 0, means 0 days. No rain was on 0 day. After that, let us simplify this. 7 choose 5. How to write this? Factorial 7 over 5 factorial, and if we subtract 5 from 7 it is 2 factorial. Well, then 0.7 raised to 5 and 0.3 raised to 2 plus 7 choose 6 means factorial 7 over 1 factorial and 6 factorial. Then 0.7 raised to 6 and 0.3 raised to 1 plus plus 7 factorial 7 factorial over 7 factorial. If we dissolve, it is going to be 1, and 0 factorial also produces 1. That's why. And zero point 0.3 raised to 0 is also 1. That means there remains only zero point 0.7 raised to 7. Zero point 0.7 raised to 7. After that, if we dissolve some of the quantities, it will show this 5 factorial can dissolve each other, and this 6 factorial also can dissolve each other. So here there remains 2 3s are 6, and 3 sevens are 21. So 21.7 raised to 5, as well as point 3 square, plus 7. Here there remains only 7.7 raised to 6. 0.7 raised to 6 into zero point 0.3 plus 0.7 raised to 7. Now using our calculator, we can easily find the probability, which is going to be 21 into zero point 0.7 raised to 5 into zero point 0.3 square, plus 7 into zero point 0.7 raised to 6 into zero point 0.3 plus 0.7 raised to 7, equal to point 647. So that is what our probability is. Okay, so I think you have understood. Whenever the total number of experiment is given, that distribution belongs to binomial distribution, and the parameters for binomial distribution is nothing but total number of experiment as well as the probability of every individual experiment. So let's move on to question number B. Question number B is just over here. Okay, let me download the page once again. No, let me erase this portion so that I can write on the same page. Yes, that is the question. Let's see what the question says. The question says, a week in which it snows on at least 5 days out of 7 is called a wet week. B. Find the probability that in 3 randomly chosen weeks, in 3 randomly chosen weeks, at least one is a wet week. So I think these also belongs to the same binomial distribution, not same, different binomial distribution. That means total number of experiment is given. Look at this. In 3 randomly chosen week, so total number of experiment is 3, and probability of each week, white week, is actually 0.643. We have already obtained from the previous question. It was 0.647. So it is nothing but again a binomial distribution. So let us start solution. X belongs to X belongs to binomial distribution, and the parameters for binomial distributions are known to us, which is total number of experiment is 3. We have already decided it's 3, and probability of each white week is 0.647. We have obtained it from the previous question. Then probability of at least 1 week. Look at this, at least 1 week. That means it must be either 1 week or 2 weeks or 3 weeks. Okay, that means it will be either greater than 1 or equal to 1. Then now look at this, total number of days is 3. So out of 3, look at this, it may be either 1 day or 2 day or 3 day. That means there is no day left when there was no rain. So it can be written in the alternative way, 1 minus, that means there is no day when there was rain. There was no rain. So how to solve this? 1 minus total number of days is 3. Out of 3, there is no day when there was no rain. So it is 0.647 is our probability of raining, which is for 0 days. Okay, then for no rain, probability was, if we subtract 0.647 from 1, it is going to be 0.353. For how many days? 3 days. Well, look at this. P is equal to, if our P is equal to 0.647, we have extracted this from the previous solution. So Q must be actually 1 minus P. 1 minus P is, if we subtract 647 from 1, it is going to be 353. Well, after that, let me try to write just below this. Yes, there is sufficient space. So it is going to be 1 minus, let me change the ink, 1 minus 3 factorial over 0 factorial means actually it is 3. 3 factorial divided by 0 factorial means 3. So let me write in short, it is nothing but 3. Not 3, it's 1, sorry. 3 factorial over 3 factorial means actually it is 1. So 1 is not necessary to be written, and this one also produces 1 as result because the power is 0. If exponent is 0, it is 1. So whole of this is actually nothing but 1. 3 choose 0 means actually 1. That means 3 factorial over 3 factorial. So there remains only this 0.353 raised to 3. Well, so ultimately our probability is going to be 1 minus 0.353 cube is equal to 0.956. 0.956. This is what our probability is. So I think you have understood. We have done the solution basing on the same binomial distribution, different binomial distribution, but category was same. Total number of experiment has been given, and probability of each experiment, individual experiment, is also given. Given means we have extracted 0.647 because this was also a white week, when on 5 days in a week there was snow, not rain, actually it was snow. So that's why probability was 0.647, and Q is not snowing days is 0.353. I think you have understood this solution as well as the previous one. Let's move on to the next question. Question number C. Question number C is on the next page. Well, let's see question number C. What does it say? It says, in a different area in the Arctic, the probability that a week is white week is zero point 0.8. Use a suitable approximation. Well, so approximation is a clue word here. Look, approximation. Whenever there is approximation word mentioned, then it is actually given binomial distribution for discrete random variable, which is to be converted to continuous random variable, means normal distribution. Well, use a suitable approximation to find the probability that in 60 randomly chosen weeks, fewer than 47 white weeks. Okay. So if we start our solution, as I have told, approximation is a word, clue word. If approximation is mentioned, that means the distribution is given in binomial distribution, which is to be converted to normal distribution. And binomial distribution is, remember, it's applicable for discrete random variable, whereas normal distribution is applicable for continuous random variable. So continuity correction is also one of the points to be taken care of. So let's solve this. As we have discussed that x belongs to, x was actually binomial distribution, and for binomial distribution the parameters are total number of experiment is 60. Okay, so let's write here 60, and probability of each experiment is nothing but zero point 0.8. Here there is 0.8, point 0.8, which should be converted. No, I should have written just below this. X belongs to, x belongs to binomial distribution, total number of experiment was 60, and probability of each experiment was zero point 0.8. Now this distribution should be converted to normal distribution. Now x belongs to normal distribution, and the parameters for normal distributions are mean as well as variance. So mean is actually nothing but np. This is n and p, n p, n into p. Actually the product of n and p is the mean. So if we multiply 60 by zero point 0.8, it is going to be 48, and then variance is actually npq. Variance is equal to n, p and q. So NP we have already multiplied 48 by 48. Q is actually, our Q is what? Zero point 0.2. If P is zero point 0.8, P is zero point 0.8. So Q must be zero point 0.2. So by zero point 0.2, if we multiply 48, it is going to be 9.6. 9.6 is our variance. Well, now we will write probability of x less than, look, the question told the probability that 60 randomly chosen weeks fewer than 47. So fewer than 47. Now the question is, why am I writing 46.5? You may remember I have already told that binomial distribution is applicable for discrete random variable, whereas normal distribution is applicable for continuous random variable. Now continuity correction is to be very important in this case. So less than 47 means actually it is 47, 6.5. 0.5 should be balanced in case of continuity correction. If it is more, we would have written 47.5. As it is less or fewer than, that's why we have written 46.5. That means continuity correction is a major part of approximation. Let's move on to the next step. So it is going to be, now we will have to standardize this score. Z less than 46.5 minus 48, I mean mu, okay, over standard deviation. You know standard deviation is the square root of the variance. Variance is 9.6. Let's find the z score. Z score must be negative. Look at this. Here 48 is greater than 46, so it is going to be actually negative. So let me calculate this. It's 1.5 over square root of 9.6. Means it is going to be minus 0.484. Minus 0.484. Well, then our z score is negative. Now we will have to draw the normal distribution graph. Let me show you the graph, normal distribution graph. It looks like this. Okay, here is midline or mean line, where is standard deviation z score is 0, and negative value must lie on the left side. So it is 0.4, 0.48. Let it be 0.4, negative 0.48. And our probability, which portion is required, our probability is this one. Look at this, because it is written less than, z less than, okay, sorry, let me change the ink. It is z less than 0.484 when standard, I mean z score is 0.484. That means this portion, this left portion is required. And you know that normal distribution graph is a symmetrical graph. So for this we can find here also point, let me change the ink, here also point positive 0.48. So the probability of this region must be equal to this region, isn't it? I hope you will agree with me that this portion, the region over there, and these two region must be equal because the graph is symmetrical. Well, and here there is zero point 0.5 as the probability left side, always left side. And one more thing should be kept in memory, that for no negative z-score there is any probability given in the probability distribution table. We are going to apply the probability distribution table. You can use the calculator for shortcut, but I'm explaining it so that it is some students may find it comfortable using the normal distribution graph. Okay, so we have decided that we require this portion as our probability. So for this portion, let me draw one more curve. Suppose this one is the curve, and here there is 0.48. 0.4 is the standard deviation or z-score. Now we require this portion. So for this portion, if we subtract, let me see, let me draw. If we subtract this portion from whole of the probability, it makes sense. Look, this only this portion. So we can easily now find the probability of the required part. We required this portion. Okay, this portion is our required probability. So for this, if we subtract whole of this from whole, if we subtract the left part, then we will get the probability of this part. So how to write this? We will write whole probability is 1. 1 minus from 1, if we subtract probability of z less than 0.484. Once again I am repeating, why are we undergoing such complication? Because using the normal distribution graph, there is no negative z-score given in the normal distribution graph. All the probability given in the table, normal distribution table, all the probability is for positive z-score. There is no negative z-score given in the normal distribution table. That's why we just convert the negative z-score to the positive z-score, because the graph is symmetrical. I think you have understood. So ultimately we require the probability of this portion. So what will we do? From 1 we will subtract the left part. Now it's time to find the probability of this z-score. When z-score is 0.484, our probability is going to be 1 minus, it is going to be 6854, then 14. If we add up, it is going to be 0.6858. 6858. Well, then after subtraction, you may ask that why am I not showing how to find this probability from z score. I'm just going to show. Let me complete the answer. It is going to be 314.314 is our probability. Now I am going to show you how to find out the probability using z-score from the probability distribution table. Well, at least you have understood so long. Only the part is how to find the probability using probability distribution table. Let me show you the table. Yes, this is our normal distribution functional table. Well, so how much was our z-score? Z-score was 0.484. Z-score was at the page number. How much was our z-score? Yes, this is our z-score. Okay, z-score was 0.484. Now, for this z-score, we will find corresponding probability. Page number 10. Okay, let me zoom it out. Yes. So our how to find, I am going to show how to find the probability from normal distribution function. So our z-score is 0.484. 0.484. It's not negative. I have already explained. We have converted it into positive. Okay. For 0.484, let's see. Zero point 0.4 is over here. Then 8 is over here. So it will be just over here. Let me show. It is just this. 0.484. Okay, so zero point 0.4, then we have got 0.48, then another 4 is over here, just over here, this portion. Okay, so our probability for 0.484 is 0.6844, then we'll add up this 14. Okay, so a point 4, sorry, 0.6844, if we add up this, how to do this addition, it you will add 0.0014, that is, it is going to be 0.6858. We may get sure that whether we have written 6858 or not. Let's go back to page number. Yes, we have written the same quantity, 0.6858. Well, so this is how we will identify this. Once again, for the last moment, I am going to show you. Our z score was zero point 4.48, then again 4. So first we will find this from this table. 0.48 is this, 0.6844 is the probability. Then for next 4, it is to be added. Here there was 14, so we have added 0.0014. So ultimately we have got 0.6858. Thus we can use the normal distribution table. I think you have understood as much as possible I could explain. So thank you all for watching the videos, and if you have any queries, you may contact me through WhatsApp. Thank you all for watching the video. Fi amanillah.